We're looking at homework from section 6.2. This is question number 12. The grade point averages, GPA, for 12 randomly selected college students are shown on the right. Complete parts A through C below. Assume the population is normally distributed. So we have 12 decimal values that were given. We want to find the sample mean, find the sample standard deviation, and construct a 90% confidence interval for the mean mu. So we're going to use technology to help us shorten this problem a bit. Let's start with part A. So on the TI-8384 graphing calculator, what we're going to do is start by pressing the Stat button. That's going to take us to the statistics screen. You'll notice that the Edit tab at the top is highlighted, along with the first choice, Edit, on the screen. If you press Enter, that's going to take you to the List Edit menu. If you have values in this L1, L2, L3 menu, you need to remove them before you do anything else. What we do after those lists are empty is we're going to enter all 12 of these values in L1. When you're all finished, it should look a little something like this. Now, once you need to do your calculations, you have to exit back to your home screen. So we're going to hit Second, and then the Mode button, and that should take you back to your home screen. It might be blank, it might have other calculations that you've performed on it, but it won't be one of the statistics screens. Then we have to go back to the Stat menu. So that takes us back to the Stat screen that we started on. This time, we need to move the highlight that's on Edit at the top over to Calc by pressing the right arrow button. That takes us to this set of commands. We are currently highlighting one variable statistics, and that's exactly what we need. So we're just going to press Enter. That's going to put the one variable stats command on our home screen. And if we press Enter again, we get the listing for all of the one variable statistics here. So we're ready to answer our questions. The first question is to find the sample mean. That's the X bar value that's given to us on the screen as 2.266666667. So we round that to 2 decimal places as indicated, which is 2.27. The next thing that we're asked to do is to find the sample standard deviation. When you use the calculator to come up with these values, the calculator doesn't know if you're looking at a sample or at a population, so it calculates both standard deviations, Sx and sigma x. Sx is the standard deviation if it's a sample. Sigma x is the standard deviation if it's a population. So since this is a sample, we're going to use the Sx value, which when rounded to 2 decimal places is 1.16. The next question that we're asked is to build the 90% confidence interval. So since we don't have the population standard deviation, this is a t-distribution problem. And whenever we're doing a t-distribution problem, we have to start by finding the degrees of freedom. Degrees of freedom are n minus 1. N here is 12 because we had 12 students that were sampled, so 12 minus 1 is 11. We then turn to the t-distribution and find where the row for the degrees of freedom intersects the column for the level of confidence. Here we're doing a 90% level of confidence, so we look for 11 degrees of freedom and 90% level of confidence, and that gives us a TC value of 1.796. We can take that value to help us build the confidence interval by first building the error. So we need our error formula. The error formula is error equals TC times S over the square root of n. Again, we're using the t-score values because we don't know the value of sigma. Inserting the values from our problem, we just came up with a 1.796 as our TC value. S was a number we found on the calculator of 1.16, and then we're dividing by the square root of the sample size, so that's the square root of 12. When we calculate this using our calculator, we get 0.6014142284. Rounded to 2 decimal places is 0.60. So that gives us our margin of error. To find the confidence interval, we're going to subtract the margin of error from the sample mean, and we're going to add the margin of error to the sample mean. So that means we're going to take x bar minus e and x bar plus e. The x bar is 2.27, so we have 2.27 minus 0.60, 2.27 plus 0.60, which is going to give us 1.67 to 2.87. And that's the 90% confidence interval for the population mean. And that's your answer.